Here is how method of coefficient works. So you have this, you get the forcing over here. Now to make it easier, you turn into a more digestible form. After that, you have a g of t. Now we need a good guess, but before that, we need to solve the homogeneous case. And at this point, I just speed run this a little bit more. But C1 and C2 cannot be just found by these two. We can't use these yet. We have to figure out the full equation because this is a characteristic equation, which is a beginning step equation. Now we need to figure out this step, which is a guessing part. How is this guess chosen? Well, if you think about it, this portion over here is like a forcing that happens like in a motor, and it will break it or it will keep on going. This is like at infinity what happens. What that means is when it goes to infinity, it's going to be a linear line like this. And as we said multiple times, with linear lines, you can't have it. It doesn't matter how many constants you add, the constants don't equal a linear line, and it doesn't matter how many linear lines you add, the linear lines will never equal the square, and so on and so forth. Therefore, this is a good guess for our particular solution. With that, we get our derivative and our second derivative and plug it back in. Why do we do that? Well, if we think about it, as we go to infinity, the line like this will show up, and the constants used for this must be the same as the used for the beginning. Therefore, that's what's happening. So over here, you can see that we did method of coefficient. We keep on going over here. And basically what we use is as this goes to infinity, this is what we see over here. And we get those constants and we find those constants here. So that's the conceptual part I understand about method of a coefficient. This is my understanding. But anyways, we go to particular solution and then the full solution. The full solution is just adding it. Now we use our initial conditions to get our constants. With those constants, we have everything to figure out the final answer over here, which gives you this wonky graph. Now, there you go. Next, we're going to do one with sine. This question is uniquely made. I purposely made it symmetric so we can cancel out over here very easily. Anyway, so we do the same thing by solving the homogeneous. Then we look at this over here, and we know at infinity we have this kind of oscillation. And I already know it's going to be cosine because of how this is going to be, and the derivative of cosine is sine, and so on and so on. But we'll move on, and we'll give you something here. We'll do the method coefficient. We'll do it again. We're getting the constant here at an infinity over here, which is what we have over here. And we so on, so on. Get this. It's all about getting